we are given equation of the parabola y equal to ax square where a is positive, and we have to show that this parabola has its largest curvature at its vertex and it has no minimum curvature. To solve that, we write parametric form of this parabola. For that, we substitute x equal to t in the equation of the parabola and we find that y equal to at square. So these two equations, x equal to t and y equal to at square, represent the parabola in parametric form. So if we have a particle moving along this parabola, then position vector r of that particle at any time t is given by xi plus yj, where x equal to t and y equal to at square. Now this is the curve representing the parabola. So if you want to find curvature of this parabola, then the formula is k is equal to magnitude of cross product of velocity and acceleration of this particle divided by cube of the magnitude of the velocity. So what is the velocity of this particle moving along the parabola? It's derivative of the position vector with respect to time. And that turns out to be I plus 280j. How did we find that? Simply take derivative of each component with respect to t. Now we find the acceleration. Acceleration is derivative of velocity vector with respect to time. Now since there is no t in the first component of the velocity vector, so we simply take derivative of the second component with respect to t and we find that acceleration of the particle moving along the parabola is 2aj. Now we find the cross product of velocity and acceleration. V cross a is given by determinant of this matrix, where the first row is ijk, second row is component of the velocity vectors, and third row is component of the acceleration vector. So the determinant of this matrix turns out to be 2ak, and this is our cross product v cross a. Now the magnitude of v cross a is simply coefficient of 2a because a is positive, and magnitude of the velocity vector is equal to magnitude of I plus 2at j, which is equal to square root of 1 plus 4a square t square. Now to find the curvature, we simply substitute these values in the formula for the curvature, which is v cross a magnitude divided by cube of magnitude of velocity, and we find that curvature of the parabola is given by 2a divided by 1 plus 4a square t square raised to power 3 over 2. We want to find minimum value of the curvature k. We see that at the top we have 2a, where a is a positive constant, and in the denominator we have this expression which is function of a and t, and a is given to be constant. So basically the denominator is a function of t. If we want to find minimum value of k, we need to maximize the denominator. So what is the maximum value of this function? Now t can take any value, positive, negative or 0. But we see that this term is positive. So we are adding something positive to 1. So that means this number is always positive, and if you want to minimize it and maximize 1 plus 4a square t square, then we need to increase values of t. But t can take any real value, right? So it can be as big as we want it to be. So this function in the denominator has no maximum. Therefore, k has no minimum value. So this parabola has no minimum curvature. We can reduce it as much as we want just by increasing value of t. Now we want to find the maximum curvature of this parabola. Now curvature is a function of t. If you want to find maximum value of something which is a function of a variable t, how do we do that? First we take derivative of k with respect to t. So the derivative turns out to be equal to this number. Now for maxima or minima, we set this derivative with respect to t equal to 0 and solve for t. Now we substitute this equal to 0 and solve for t. What do we get? This is a constant, so it doesn't matter. Now 8a square t is multiplied with this number. There is no value of t for which this number is 0 because we have 1 plus something positive. So it's never going to be 0. So basically this derivative of k with respect to t is 0 only when 8a square t is equal to 0. And that happens when t is equal to 0. So if this function has maxima or minima, it occurs at the point t equal to 0. Okay. If second derivative of the curvature k with respect to t is positive for this value of t, then we get a minima. If second derivative of k with respect to t is negative for this value of t, then we get a maxima. So first let's find the second derivative of curvature with respect to t, and it turns out to be equal to this function. Now let's check its value for t equal to 0. So when we substitute t equal to 0, we have a t multiplied with something here. So this second term will become 0 for t equal to 0. And in the first term, when we substitute t equal to 0, we'll be left with just 1. Okay. So the second derivative of k with respect to t at t equal to 0 is equal to minus 24a cube. Since a is given to be positive, so this number is going to be negative for t equal to 0. So that means k has a maxima at t equal to 0 because the second derivative is negative at t equal to 0. So what is this point t equal to 0 on the parabola? Since the parametric form of parabola is x equal to t and y equal to at square, for t equal to 0, we are at the point x equal to 0 and y equal to 0, which is the vertex of the parabola. So basically the curvature has its maximum at the vertex.